Good evening, class. This is Jacob Darbone. I will be presenting on databases. This was recorded on 3/11/2018 for ISA 4220 with Andy Green, the spring semester of 2018. So for a brief overview, we'll be talking about EMET for Windows, both its origin and techniques to harden it, as well as Postgres or PostgreSQL for Linux, and its origin and techniques to harden it as well. EMET, or Enhanced Mitigation Experience Toolkit, is a utility that helps prevent vulnerabilities in softwares from being exploited. It was created for Windows Vista and Server 2008, as well as the later iterations of both OS, so Windows 8.1, Windows 10, Server 2008, 2008 R2, 2012, and 2012 R2. It was created in 2009 and has recently been discontinued, but will be maintained till July 31st, 2018. The software works as a mitigation security technology by creating special protections and obstacles that a hacker must work through to exploit a software. In layman's terms, you're pretty much setting up a bunch of obstacles or like roadblocks in a hacker's way that they have to navigate through just to get into a certain software or your computer or whatever the mitigation software is being set up for. So it pretty much delays them and makes them have to invest more time and effort and resources into getting in. So it can usually deter them through that unless they have advanced software. Sorry. The utility isn't foolproof though at securing software, but it attempts to make it as hard as possible for hackers to get into. So it is not a perfect software that it can secure your network or your system 100%, but it does help in deterring hackers from attempting to get in. And it also provides a configurable SSL TLS certificate pinning feature. And this feature is called Certificate Trust, which pretty much just allows you to identify and configure certifications that will allow you to have more secure connections with software and URLs and such. And it can be used concurrently with other programs to make your database and OS even more secure and harder to get into. So not on top of this, you could have firewall policies and other antivirus software and things of that nature that could also add obstacles to hackers' attempts to get into your system. Next, we will talk about hardening techniques. So with EMET, you can set up policies. So you want to make sure that those policies are set up accurately so that they cover the software you need protected. You will also want to ensure that your policies don't conflict with one another. So you don't want to have overlapping policies that could cause both to fail, which would leave vulnerabilities in your system. You also want to make sure you protect the services you need to run and delete the other services you don't need for safety reasons. What we mean by this is a lot of times services will come on the servers that we set up that aren't necessarily needed or that we won't be using for the server. So you want to make sure you delete or disable those services. You don't want these services to be open or unmonitored because that just leaves more access points for hackers to get into. So you want to make sure you close those off and protect the services you do need to run. And lastly, you want to watch what ports are open and closed to ensure you leave all possible avenues of attack protected. So if you're using SMTPS or POP3S or anything like that, you want to make sure those ports are safely protected, and ports that you won't be using are closed. Kind of similar to the services, you don't want ports that you won't be using to be unmonitored or unprotected. That could cause issues later on down the road. So next we will move on to PostgreSQL and its origin. It is an object relational database management system, and it's usually called Postgres for short. It emphasizes extensibility and standards compliance. Its primary functions are storing data securely and returning the data in response to a request from other software applications. Its workloads range from single machine applications to large internet-facing applications, so it has variability in the amount of data it can handle and the size of the database that you can actually have. And it was created in 1996 and works for both Linux and Windows. It manages concurrency through a system known as multi-version concurrency control, or MVCC for short. And it gives each transaction on it a short glimpse of the database, allowing small changes to be made without being visible to other transactions until the changes are committed. So pretty much anytime a software or something of that nature requests access to the data, it only allows a short glimpse rather than opening it up fully. So if somehow a hacker got into one of those services and is trying to get into that database, they only have a short time to look at it rather than having full access. And multiple transactions will not be visible, or will not see the changes being made visibly to that database. So it allows databases to, not databases, I'm sorry. It will allow softwares to access that database concurrently, but not allow each software to see what is being accessed. So if a hacker does get into one, they can't see what else is happening on the database. And it largely eliminates needs for read locks. And this database maintains animosity, consistency, isolation, and durability. And it offers 3 levels of transaction isolation. Those 3 include read committed, repeatable read, and serialize. And lastly, it's a user-defined objects are included as well, and it ranges from casts, conversions, data types, functions, indexes, operators, and procedural languages. It includes B-tree and hash indexes, and there's 4 methods of accessing these indexes. You have generalized search trees, or GIST for short, generalized inverted indexes, or GIN for short, and space partitioned GIST, SP-GIST for short, and block range indexes, or BRIN for short. Next, we'll move on to hardening techniques for PostgreSQL. It runs on a per role basis, of which each role is usually regarded as a user, or each user will have a role that is assigned to it on accessing that database. So different users can have different access availability, or more access to the database or less access depending on their role in the company or their need to access that database. You want to make sure your password setup on this are unique and hard to guess. Each user has their own, so you want to make sure that users can't guess other users' passwords who might have more access to them. So you might want to randomly generate those passwords, or do what you can to make them as unique and hard to crack as possible, as to not be broken in with using a brute force attack or a rainbow table. So making sure those passwords are unique and hard to guess would be important. You also want to create separate roles for each application. This ensures that you can separate users and data to restrict access of certain users to certain data that they may not need to see. So this goes back to the roles you can create, and you want to ensure that people that need a lot of access to the database have that access, but those who don't need as much access or even access at all are blocked, so that they can get into the database and see things that they aren't supposed to, or that may not be related to their jobs. And lastly, you want to not allow remote connections. So what this means is you don't want to be able to remote into this database. That can cause unsecured connections to be created if you don't do it properly, which a hacker could see that connection and break into it, or somehow find out how to do it themselves. And remoting in is a not very safe way of accessing the database. So in regards to that, you can use SSH for safe connections, and through SSH you can create tunnel access to that database. So if you create that tunnel through SSH, that is a very secure and strict network connection that will allow you to have safe and encrypted connection to the database through remote access, which would prevent hackers from being able to see that connection and get into it. So that is a very safe way. And with that, we end our presentation on databases, both EMET and PostgreSQL. So I hope everyone has a wonderful night, and I will see you again for the next presentation. And here's my works cited page. Good night.